Hello, it's Alex from Blue Lightning Software again. I just want to continue from the last video looking at tasks accessing the main thread of Unity. I was kind of cut off. I was looking at, you can't put a burst compile on anything outside of a job struct, I think is the way it works. Talking of jobs, jobs are Unity job system that we will look at possibly in the next video, because it's kind of it leads on from this as to what is a good idea and what's not a good idea, to actually just look at the timing of multi-threaded tasks for maths is kind of what we're doing here for some mathematical stuff. Now we've got this one here in the delay. Well, the way this works now is that we can just run this without the configure await. It can access a Unity thing in the middle of it. That's what I wanted to show. The other way of doing this, okay, and I'd just do this layout here. We'll ignore these two lines because this alone proves if it has accessed the I mean, this works fine, but if I would wrap these tasks like this, using these as actions to create new threads that cease to be after they end, rather than when you do the configure await, this would cause the errors. This line here as you try to access Unity API. Now the time, and this is what saves us all the time, starting this Complexio mostly. I mean, the delay has to kind of be as well in its own thread, which it does automatically, but this saves us the time. However, if we wanted to just completely stay off this thread, if we wanted to run this like this and have configure await the other way of getting off, and then this is forced into a new thread as it comes back from configure await. I'm not sure I want to type this out, but here we go. There's queue, action queue. Okay, so we could use a new queue of actions. I'm not even sure this is going to work. It should work, all right. This is one way to do it, okay. And what you do is this is then placed into its own action. Okay, so we would have voids, call it voids, get transform, because that's all it's doing is this. All right, so we would then be loading the action queue with that. Action queue dot on queue on queue. I think it would be. Do you have to make it an action with like the brackets and stuff? Yeah, I guess we do. Okay, so that's setting this to an action, and we've on queued that. And then what we do, this weirdo method, not weirdo, I mean, if there is a way, it works, okay. We would dequeue this. We would have this here in the update. Now the update is always going to be running back on the Unity main thread. Okay, so while action queue dot count, it's going in the 0, do some stuff, because you're going to do a bit more actually. We've got to do, because I'm taking this out, I'm doing this, you could do this as one probably. So we do action dot invoke, okay. what's wrong with that? Okay, we're accessing action queue over multiple threads. Alright, so we've got to lock it like this. Alright, this is the old style threading stuff. You know, you got to lock the action queue during this. What performs inside the braces is now locked. We have locked the action queue to other threads whilst we do this. Okay, so we empty it, yeah, and invoke whatever actions were placed inside it. So, and we do the same here. So I'm not even testing if you need braces yet, but never mind. So we've got that. Now, okay, what we're doing is every time we lock the action queue for thread safety, we on queue get transform. Okay, so we come out with configure await. We're in a different thread. Within that different thread, not the main thread, we on queue the action get transform, which does just that. Look at the transform. We then still not in a different thread to the main thread. We complete complexio, thus it's not slow. Okay, the math gets done fast. In the update loop, it's performing all of these. All right. We can prove it afterwards. Okay, let's have a look at that. This, I think, unless it's miraculously quick on the overheads, I'm not 100, and I think it might be slower than just what we had before, the await task, run, complexio, and not configure wait, and then just this in there. So this became back to the main thread and then out to complexio. But anyway, let's see if this works, because you know it seemed okay at the time. Run it. Seems about the same. I mean, this would be 10,000 milliseconds. It's not old. I mean, that's an average. On average, you click it. It depends what's going on my computer. So hard to measure because it's really dependent on background processes that are hogging the CPU almost as much. Okay, so it looks about the same. Can we prove what it's doing? We could add some more stuff. We could add more stuff to what's going on in the action get transform. We could say increase the Y of the object get stuff. The object, we're doing all this within test stuff. Get transform, add Y. Okay, so now this is all going to be on queued, and we can visualize. We could have made an object move up the screen, right? It would have been more obvious, perhaps. But let's have a look. Let's just check it works. 10,000. Let's have a look. So we got test stuff here, and this is the game object. The transform of that we are looking at is this transform top right, if you can see it. Y is 0. Let's see what happens when we press task now. Oh God, is it working at all? That's not moving, is it? We'll botch this up somehow. What's going on? So hold on, I'll do that a bit quick. What's going on? Position.y equals transform position equals y. Debug.log Unity engine.debug, because we've had to get a system in to do some of this. That's kind of how I look at stuff. Something like this. So, is that even calling? Is it flawed? What did I write? Hold on. All action Q. Action equals DQ. Invoke. Which would run that. Yeah. Did that even work? Let's have a look. Slowing ourselves down with a bit of debug now, but it doesn't matter. Let's see. Well, there we go. Yeah, I mean, it's saying that something was changed. The transform. We got the wrong transform. So yeah, there we go. It's up to 10,000. It was an editor visualization thing. You're gonna have to trust me on this. Let's set it to 0 again. Let's do it with our eyes open. Yeah, there it goes. Yeah, it's probably one of those I didn't have it compiled previously. Unless the debug is forcing the editor. Let's remove the debug. But you can see, yes, that did work. It accessed. That slower time there is probably because of the debug. Let's take out the debug, if that makes sense. Or it could just be my background processes. But it did what we wanted. It used that queue to queue jobs. That it actions, and you could put anything in there. You could put any action into a queuealizer. You could have a static object somewhere with just an instance that only does this on its update. That is just clearing that queue that we could have added to here. You know, we could add an add function with a lock or whatever. That might get a bit more confusing, but let's look at that one last time. Just see if it does it without the. I think it's not sometimes tough. If you run a load of stuff really quickly, the circumstances under which the editor updates this during runtime, during play of the editor. Let's have a look. Yeah, no, it works fine. 649, 1000. You're going to really struggle. Actually, there's almost a suggestion that it has the edge there. Mildly, I mean so mildly, like these are all coming in under 1,000, and that's very dependent on what I'm doing in the background. So if we went back to the old way of doing it, which is this followed by this. And then not that, and not this. We'll try and bunch these up so that we can put them back easier. And then not that. Okay, so this is kind of the old way. It doesn't configure a wait, stays in the main thread, does that, and then goes out to a new thread, which is maybe taking microseconds more. I don't know. It's so hard to. It's not that hard. I mean, if I just stopped running stuff in my box and clear my computer out and just ran these tests probably next to each other a few times, we can maybe get a feel for which is definitely quicker or not. Outside times it's a tiny bit quicker. Let's see. Alright, that's 1,000. 10,000. No, that's nonsense. See, it's well. How many times you clicked it? Honestly, what, 10? Alright, these look like 10 something every time, don't they? More consistently. Just say test boolean. Just do one or the other. All right. So there's possibly something to the task overhead that we're missing here by queuing these into the main thread. That this is a tiny bit faster, maybe. Let's have a look again. Test. Whoops. Oh dear. Press play and then test. Only enters for 10,000 ones. No, it's to do with the state of my computer. It's the same. I can't prove or disprove that that one method appears more complicated than the other. I mean, suppose you wanted to, in the middle of something like an action, you had this math function. It depends how you're wrapping it up. Within Complexio itself, like this, within its new thread, you wanted to say every time this word round, every Complexio, you wanted to call get transform y. Void add action to queue. All right, so staying. This would be just this. Have fun with the actions, you know. See, we just replaced that with that. Alright, so now this is the lock. So anywhere we want to add an action like this, we would not bother repeating the lock. We could do it here, okay? And we could close that. If we did it like this, it'd be horrendously... No, sorry, this would not be. This, because we leave configure await in, okay? What this is saying is now within Complexio, it's going to, which will now run on a separate thread to the main thread because of configure await. Complexio itself can now add to queue the get transform, the stuff on the main thread. This get transform add y can be added to that queue, and that will run on the main thread within its little update loop here. Okay, let's just check that works. It should do. Pardon me. Did I have this stopped when I pressed re-import? So a easy look at that. So I mean, this maybe syntactically. I mean, it depends how you're writing or what you're writing. If you want to wrap it up with all task waits every time you go off. And then Complexio has to not contain any of these. I mean, it could then contain this if you were using this method. But if you didn't have this queue and the update loop somewhere in your system, you wouldn't be able to run tasks that access the main thread at all outside of this format of kind of task run within tasks. The start new thread bits all task run, and the main thread in the middle and no configure await. So I think we got that. We definitely imported that. Let's have a look. This should just work, I imagine, and be the same kind of speed. It's just for flexibility. Maybe this makes sense to somebody. I mean, it's going to be the same timing. There's no way it's different. Obviously it's always going to be the same. It's just cycles within my computer, whatever else it's doing. To you, the floating point, your thing has blown up. You've set it too high. Let's put that back down to 0. Yeah, I mean, that looks fine. potentially it's got a micro gain. I don't know. I don't think we've proved that is faster at all, but it is possibly more flexible. If you wanted to access the main thread from within a different thread, you could do something like this. Let's put these together with a queue. Where'd the queue go? With this queue. And just remember to lock it. So this code here. What? Am I getting dumb? Here, yeah, here. Oh wow, look, fumbles. There we go. So this is all you need to get that external queue, just these bit of code here. Passing those actions around, add action to queue, pass any action in. Call this from any thread, this add action to queue. You could make this, I think even in this example, you'd have to make see what I mean? That would work. Okay, and this object, you could then have an object purely for dealing with this. You could just have a mono behavior with the update loop on the main thread doing this. Just that code there will deal with that. What I'm going to say now probably invalidates everything. Not invalidates it, but makes it kind of useless or not. The overhead of doing any of this stuff I think it's going to get flattened by job system, because the amount of work that is needed for it to make sense is massive. I mean, Invoke's not... How many times, how many iterations before that kind of breaks even? This is comparing the overhead of an Invoke. Oh, because it's in Complexio now. Oh, wow. So this is Invoke's doing the work as well of raising the Y. So quick, though, with Invoke. It's 100 times. Maybe, yeah, about 100 times. So if it's not impossible, it depends what kind of... I avoid crazy math within the frame rate settings, if there's the structure of the game. Personally, I guess all the way I've kind of avoided doing anything really heavily mathematical from various places within a frame, but it's definitely going on. My difficulty is there's a lot of stuff that's accessing objects within the game. I mean, if you haven't gone straight to an entity component system and you're stuck in dots, are not in dots, you could look at this. I mean, the overhead overlap, 100 iterations of that Complexio function 10,000 times. I mean, technically, is that the same? Doesn't it independent of repeats? No. No. No, and it becomes apparent with a line of repeats. So, I mean, it's around that point, the overhead of the tasks is less than the overhead of the Invoke. The time it takes, the tasks run faster multi-threaded than Invoke would run single-threaded, given the overhead of the tasks is around that point. There's a tipping point somewhere, but it's doing a lot of maths. It's 100 iterations of this dumb function. So you know, it's kind of yeah, it's not really what it was designed for. I mean, I'm going to look in the next one at jobs. I've got to set up the Unity job system. You know, I'm not really been doing much of that myself, but I'm going to look at it a bit more so that I can just run through some examples. I don't think it'll even be comparable if we did tasks versus jobs, particularly on stuff where this overhead. I reckon jobs are going to work with a much lower overhead for smaller mathematical tasks, like if it was one iteration, 10, not necessarily 100. It's probably even quicker on 1,000. It probably outpaces on all levels. So we'll just experiment with that. This is what stopped me diving in and just using dots or burst, because the burst compile that you're going to get with the job is going to run miles faster than any mathematical function. Just using the burst compiler with the jobs will give you a huge boost. So yeah, I think jobs are going to win by miles, but it'd be interesting. Maybe we can look at the tipping point of jobs. Like, is it 10,000 times 100 of complexio function, this bit in the middle, 1,000,000 times loosely running that in a frame? By that point, this kind of amount of math, you would be multi-threaded task would be mildly quicker. And then it starts winning by a bit. Every time you add up, it will get more and more, it just start winning by a bit. Folks quite slow now, yeah. So, if you were doing very math heavy stuff, didn't have job system, you might use the task for this. But we'll look at the next one. I mean, tasks more for like opening files and stuff. Do you know what I mean? That tend to async on separate threads anyway. Usually, file reader stuff or the API calls for that. Anyway, thanks for watching. I'm going to try and get the jobs set up for the next one. All right, thanks a lot.